Practice video for Chapter 11, Computational Complexity. Explain your answers with a single verbal sentence or a short proof. A. Given X is an infinite set of strings where any string S, element of X, satisfies a certain property. For a given string S with a length of, this is showing the length of S, assume that AS is the solver of the decision problem, is S element of X. You are also given the certifier CST, where T is some string. Part 1. Given string S1, A S1 is yes. The question is it possible to find some T1 where certifier S1 T1 is yes? The answer is yes. Because the definition algorithm CST is a certifier for string matching problem if for every string S element of X, if and only if there exists a string T such that CST is yes. The next question is it possible to find some T2 where CS1T2 is no? The answer is again yes. As X is not the universal set, there should be at least one. The given part is the same. We continue with the second part. Given string S2. Certifier S2 T3 is no. Is it possible to find some T4 where C S2 T4 is yes? The answer is unknown. An answer no from a certifier does not give any information. So we cannot know whether is it possible to find such a string saying yes or not. The next question is, now you learned that AS2 is no. Is it possible to find some T4 where CS2 T4 is yes? Explain also your reasoning. The answer is no, because the algorithm itself is saying no. So if S is not in X, then CST will say no for all T. Because of that, it is not possible to find some T4 for which the answer of the certifier is yes for the problem instance S2. The third part, given AS is polynomial of S, what is the lowest complexity of some certifier CST? The answer is use AS as certifier. So we have a certifier which is polynomial. Part B, 1. Given problems Q and R. Problem Q has no polynomial certifier, and it is given that R is polynomially reducible to Q. Choose your answer among P, NP, NP complete, and NP hard. The question is, what are the possible problem complexity classes for Q? The answer is Q can be NP hard or exponential. Because we don't have a polynomial certifier, Q cannot be NP complete, because for being in NP, it is required to have a polynomial certifier. Because of that, Q cannot be NP complete, NP or P. NP complete and P are the subset of NP. What are the problem complexity classes for R? R is polynomially reducible to Q, but Q can be NP hard or exponential. R can be NP complete, NP or P, exponential or NP hard. This is not given information about the class of R. 2. It is given problems P, M, and M. Problem P is polynomial. Problem M has a polynomial certifier. Problem N is NP complete. Write and justify all possible polynomial reducibility relations for P, M, and N. We know that P is polynomial, and for NP, P is polynomially reducible to M. M is in NP. And we know that N is NP complete. This guarantees that any problem in NP is polynomially reducible to N. So we have this relation between these problems. And also, if it can be shown that M is NPC, in that case, we can say that also N is polynomially reducible to F.